This is Deep Learning Lesson 3. Today's task is in the provided code, in the given source code, it is provided with the code in which there are some 3 mistakes are there. We need to correct them. This one is the today's first task. Here we are importing all the necessary packages and reading the dataset. The dataset is IMDb master. I am reading the values of the dataset using the encoding Latin one, and there are labels, reviews and label. See, in the given dataset there are type, review, label and file. I am reading the values of the review in sentences and value of the label in Y. Using the tokenization, I am dividing the sentences into the words, and using the text to matrix, I am converting it to the matrix form. And these sentences are categorical values. In order to convert these categorical values to numerical values, we use label encoder. Here we are splitting the data into test data and the train data, and here we are using the network layer. We are forming the neural networks using sequential model. This is the input layer where the input dimension is given as 2000, as the number of words is 2000 given to the tokenizer. This is one of the mistake which is given in the source code. We need to replace this input dimension, and for the output layer it is given as the activation function as sigmoid. We changed it to softmax. After that, I am compiling the model using the loss function sparse categorical cross entropy with the optimizer Adam and metrics as the accuracy. This is the history training the model, and we are evaluating, and this is the result. Here we are plotting the graph for accuracy and the loss. Here we are predicting the here we have taken the sample data and predicting with the test data. We will run this code and see. Now we will run and see. Here I have already run the first task using Python task1.py. Here we can see the results. The evaluation result, the loss is 0.87 and the accuracy is 0.5. This is the loss model. This is the accuracy model. If you see, the train data accuracy increases with the epoch, where the test data accuracy is remain constant, and at some point it even decreases. This happens because of the set we have considered. We need a better data set in order to get the more accuracy. This is the loss graph where the train data set has the reduced the loss when with the increase of the epoch. Even here the test data set is has the higher loss, and we have taken a sample and predicted it. We have taken the value as 2 and we have predicted it as 2. Now we will see the second task. We need to add the embedded layer to the model and need to see the improvement. This is the task 2. It is almost same as the first task, but only few changes we need to do here. Here we are using the max review length by splitting the. Here we are finding the max length of the word in the given sentence and passing it to the sentences, and here we need to find the padded doc by passing the max length which we have found from the largest word in the sentence. This padded doc appends the 0 to the small. We need to find the vocab size from the word index with +1. This we need to find because we have to consider the length of the largest word in the given sentence. And here we use the label encoder as discussed earlier in order to convert the character values to numeric values where computation can be done and the predictions are easy. In order to convert it, we need label encoder. Here we are splitting the data and training the data. Here we have added the embedded layer by passing the vocab size and the max review length, and then added flatten, and the same the input dense layers and the neural networks with input dense layer and the output dense layer. Here we have given the output as 3 because we have 3 different class labels as the output. That's why we defined the 3 neuron layers. We have compiled the output, and here where we are training it, and we are evaluating the model, and this is where we are printing it. And I am plotting the graph, and the same thing I am taking the sample and with comparing with the actual value. Now we'll see the result. See here we got the result as loss result as 0.97 and the accuracy rate as 0.48, whereas in first program the accuracy rate is 0.50 and here the accuracy rate is 0.48. Here the accuracy rate is decreased a little bit. Actually added a new embedded layer, the accuracy rate has to be increased, but based on the accuracy rate increase and decrease will based on the data set. It has very less number of columns in order to calculate the predict the output. That's why the accuracy level is reduced. If you have a better data set, the accuracy level will be increased. And again in this data set I have considered the sample data as from text with the index 8. The predicted value is 0 and the actual value is also 0. It is predicting almost correct. The third task is we need to use 20 news group datasets from the Skyline datasets. Now the same thing here we are using, but in order to use the IMDb dataset, here we are fetching the data from the Skyline 20 new groups by giving the subset train and shuffle true. There are in this dataset there are 20 different categories. The same thing again we are doing it with different dataset. Now we will run and see the output. With this model we are getting the accuracy, we are plotting the accuracy graph. Here with the train data the accuracy is increased with the epoch values. For the test data the accuracy is good when we compare to the previous data set of IMDb. Here the accuracy is increased. Now we will see the lost data set. Almost for the train data and the test data the loss is also the same. Yeah, here the loss percentage is 67% and the accuracy is 82%, which is far better than the previous dataset. It depends completely on the dataset. Here I have covered these bonus questions in each and every question, plotting the accuracy and the loss for him, and predicting over the sample data and checking with the I have done these both with all the 3 questions. Thank you.